What if Earth had rings like Saturn, Jupiter, Saturn, Uranus, and then Earth? Imagine waking up one morning, looking up at the night sky, and seeing giant glowing rings arching across the heavens. Not from Saturn, but from right here on Earth. What if our planet had massive rings orbiting it like a cosmic crown? Would life be more beautiful, or would it come crashing down? This is What If, and today we're asking, what would happen if Earth had rings like Saturn? Let's rewind the clock. Not just a few centuries or millennia, but billions of years. Earth, as we know it today, wasn't always the blue and green marble floating peacefully in space. About 4.5 billion years ago, during the chaotic birth of the solar system, Earth was just a molten ball of rock, constantly pummeled by leftover planetary building blocks. It was wild, violent, apocalyptic. And then came Theia. Theia was a Mars-sized planet, or at least a massive protoplanet, hurtling through space, minding its own business, until it slammed head-on into Earth. The force of this collision was beyond comprehension. Imagine an object the size of an entire planet smashing into another at tens of thousands of miles per hour. It didn't just shake Earth, it reshaped it. The impact vaporized huge portions of both planets. Massive amounts of molten rock and debris were ejected into space. Some of it escaped Earth's gravity completely, disappearing into the void. But much of it didn't. Instead, it started orbiting the Earth, forming a glowing halo of molten rock, stretching out like a fiery wreath. A ring system, similar to what we see around Saturn today. For a brief moment in the young solar system's timeline, Earth had rings. But here's the twist. They didn't last. Over the next tens of millions of years, gravity worked its magic. The debris slowly clumped together, merging chunk by chunk into a single spherical body, and eventually formed something we're all familiar with, the Moon. Today, we look up and see one lone satellite lighting up the night sky. But imagine, for just a second, if things had gone differently. What if that ring system never coalesced? What if the Moon never formed? Instead of one solitary orb, we'd see enormous shimmering bands of rock and dust arching across the sky, glowing at dusk, glowing at dawn, never disappearing. Depending on where you stood on Earth, these rings might stretch from horizon to horizon, painting the heavens in bright streaks of silver, bronze, or even reddish tones, depending on the minerals in the rocks. At night, the rings would outshine the stars. During the day, they might filter sunlight, casting unique shadows or rainbows across cities and forests. Think of the art, the stories, the cultures we'd have created around this ever-present spectacle. No moonlight poetry, just ring-light legends. But it's not all beauty and wonder. If Earth had rings like Saturn's, especially if they were made from rocky debris instead of ice, it would change everything. These rings wouldn't just float up there, minding their own business. They'd interact with our climate, our atmosphere, even our evolution as a species. Depending on their width and density, they could block sunlight over large parts of the planet, especially near the equator. And in a young, fragile ecosystem, even a small drop in sunlight could shift the balance between survival and extinction. And remember, no moon means no tides as we know them. The Moon plays a critical role in regulating Earth's tides, which in turn influence ocean currents, weather patterns, and even life's evolutionary path. Without it, Earth's environment could have looked and functioned very differently. Would complex life have ever emerged? Would humans even exist? Maybe. Maybe not. It's one of those cosmic what-ifs that makes you pause and appreciate how delicate the balance of life truly is. One slightly different outcome in a massive planetary collision billions of years ago, and the world we know today might never have formed, and yet, what if Earth had kept its rings, and life somehow still managed to evolve? That brings us to the next big question. Could we survive if we had rings like Saturn today? Let's find out. So, let's imagine for a second that Earth never had a ring system. The ancient debris from Theia never stayed suspended in orbit. The Moon was born, just like it actually happened. But now, in a modern age where we manipulate atoms and explore Mars, one bold question remains. Could we build our own rings today? Well, technically, yes. But the method would be nothing short of catastrophic. To create planetary rings the way nature does it, we'd need a massive object, say the moon, to be broken apart and turned into orbiting debris. And while that sounds like pure science fiction, there is an actual, very real physics concept that would make this possible: the Roche limit. Here's how it works. Every celestial body exerts a gravitational force, but that pull isn't the same everywhere. It's stronger on the side of a nearby object that's facing it and weaker on the far side. If a moon or any other large object comes too close to its planet, past this invisible boundary, those uneven forces start to pull it apart. For the Earth-Moon system, this Roche limit is about 9,500 kilometers from the Earth's center. Right now, the moon orbits us at a safe distance of nearly 384,000 kilometers. But if, somehow, we nudged the moon closer, slowly, carefully, until it dipped just beyond that critical limit, we'd witness something truly apocalyptic. The moon would be torn to shreds. It wouldn't explode like in the movies. No giant fireball. But it would unravel. Over hours or days, tidal forces would stretch it out, cracking its crust, tearing through its mantle, and releasing a colossal cloud of dust and rock into orbit. These billions of fragments would begin to circle the planet, spreading into shimmering bands that could form the kind of ring system we now only see around gas giants like Saturn. But hold the applause, because while the rings might look breathtaking, the side effects would be devastating. First, let's talk about tides. The moon plays a crucial role in driving Earth's tidal systems, the gentle, rhythmic movement of the oceans that helps regulate everything from climate to marine life. Without the moon's pull, the tides would shrink dramatically. Coastlines would change. Species that evolved to rely on tidal flows would struggle to survive. Coral reefs, spawning cycles, and coastal ecosystems would collapse almost overnight. Next, ocean currents. The moon influences how heat moves across our oceans. Without it, the oceans might stagnate, throwing weather patterns into chaos. Winters could become harsher, summers more unpredictable. Storms might increase in intensity. Entire climate systems could shift in ways we can't fully predict. And we haven't even talked about life on land. Many species, including humans, are sensitive to the moon. No, not in a mystical way. But the moon's presence affects the Earth's axial tilt and stability, which helps regulate the length and consistency of seasons. If you remove that celestial anchor, Earth's tilt might wobble wildly over time, leading to extreme climatic changes across millennia. Then there's the subtle stuff: animal migrations, mating cycles, even human circadian rhythms. The internal biological clocks that regulate our sleep have evolved under the steady glow of the moon. Without it, the night sky would be darker and unfamiliar. Animals that navigate by moonlight, like sea turtles, birds, or certain insects, would lose their sense of direction. Whole food chains could crumble. And just imagine the psychological effect on humans. For thousands of years, we've gazed at the moon as a constant companion, in poetry, in love, in science. Losing it would be more than just a scientific event. It would be an emotional rupture in our collective story. Still think the rings would be worth it? And even if we survived all of that, no tides, climate instability, confused animals, sleepless humans, we'd be living beneath a halo of deadly space debris. These rocky rings wouldn't be made of shiny ice like Saturn's. Earth is too close to the sun for that. Instead, the rings would be dusty, jagged, and fast-moving. Like a sandblaster in space, orbiting at thousands of miles per hour. We're talking about billions of chunks of moon rock flying around the planet, constantly colliding, grinding, and posing a serious threat to anything in their path, especially satellites. But that's a disaster for another part of our journey. So sure, yes, we could create rings around Earth. All we'd have to do is destroy the moon, destabilize the oceans, throw the climate out of whack, and gamble with the survival of most complex life on Earth. Sounds like a fair trade, right? Coming up next, let's look at what happens if those rings actually form. Could we even survive in their shadow? At first glance, Earth's rings would be the most breathtaking thing the human eye has ever seen. Stretching as wide as 3,000 miles and orbiting around the equator, they'd paint our sky with cosmic ribbons, ever-present, ever-changing with the angle of the sun. From many locations, you'd be able to look up and see them at any hour, in the faint blush of dawn, or even during the high noon sun. At night, they'd outshine constellations. During the day, they'd carve the sky into slices of light and shadow. Imagine sitting at a beach in Florida, or standing on a rooftop in Sao Paulo, and seeing a massive arc of shimmering stone sweeping across the sky. Not in a straight line, but a curved spectacle, like a stadium light wrapping the globe. Depending on your latitude, the rings might appear as towering arches, or from closer to the poles, a thin, mysterious line across the horizon. Poets would write about them. Artists would obsess over their glow. But beyond the visual magic, there's a much darker reality. Because these rings, especially if they were formed from crushed moon rock, would be made of dense, rocky debris, not light, reflective ice like Saturn's. That means they wouldn't just sparkle, they'd block. And what they'd block is something Earth desperately needs: sunlight. Depending on their density and tilt, Earth's rings would cast vast shadows over large swaths of the planet. Some regions could find themselves permanently shaded for weeks, months, or even all year long, not because of clouds, but because of cold, unyielding rock hanging in the sky. And when sunlight can't get through, everything starts to fall apart. First, there's photosynthesis, the process plants use to turn sunlight into energy. Less sunlight means fewer thriving plants. Trees would grow slower, crops would wither, grasslands would fade, the global plant biomass would shrink, and with it, our planet's ability to produce oxygen and absorb carbon dioxide. It's not just about food, it's about the air we breathe. This would trigger a domino effect across ecosystems. Herbivores would struggle first, as their food supply dwindles. Then predators, as prey populations collapse. Forests would thin, biodiversity would suffer. Entire species might go extinct in the zones most affected by the ring shadows. And then comes the climate side of the story. With less solar radiation hitting Earth's surface in those shaded regions, temperatures would drop dramatically. Think of these ring shadows as permanent solar eclipses, casting long, cold shadows across countries, continents, oceans. Places that once basked in tropical heat might find themselves stuck in a chilly twilight. Frozen tundras could expand, overtaking farmland, shifting climate zones, and changing the map of habitable Earth. But the rings wouldn't distribute their shadow evenly. Unlike clouds, which move and vary, ring shadows would be predictable but unmoving, creating permanent zones of darkness while leaving other regions totally sunlit. The result? A planet divided. On one side, regions might suffer ecological collapse from too little light. On the other, unshaded areas might overheat, experiencing more direct solar radiation, increasing evaporation, and suffering through brutal droughts. Now imagine the political and human consequences. Would nations in sunlit zones hoard food, water, and resources, while shaded nations struggle to survive? Would climate refugees flee the shadowlands in search of habitable territory? Wars have been fought for far less. And it's not just the plants and weather. Countless animals rely on the moon, stars, and sunlight to navigate. For migration, mating, even hunting. Birds, sea turtles, insects. They all depend on natural light cues to find their way. Under a new ring-lit sky, those familiar cues would be distorted or erased. The moon might be gone entirely, having been turned into the rings. Starlight would be drowned out by the glow of dusty rock. Many species would become disoriented, lose their migration patterns, or cease to breed entirely. Even humans would feel the impact. Our internal biological clocks, called circadian rhythms, are synchronized by sunlight. They tell us when to wake, when to sleep, when to eat. Disrupt those cycles, and you get insomnia, depression, hormonal imbalance, and long-term health issues. Populations living in the perpetual twilight of the ring's shadow might face entire epidemics of mood disorders and immune dysfunction. And here's the kicker. The rings wouldn't have to be incredibly thick or solid to cause this damage. Even a partial light filter, stretched over thousands of miles, could make regions just dim enough to shift the balance. And that's all it takes to unravel an ecosystem. It's a sobering thought. Something so visually beautiful could be ecologically deadly. Rings around Earth might give us the most stunning skies imaginable, but they'd also bring about one of the most. When you look up at the sky and imagine shimmering rings encircling Earth, it's easy to think only about the beauty. But beauty, in this case, hides a catastrophic cost, and it's not just about ecosystems or sunlight anymore. It's about technology. Modern life, as you know it right now, runs on a web of satellites silently orbiting high above the Earth. They do more than help you find the nearest Starbucks or stream a Netflix show. They guide planes, control cargo ships, process bank transactions, monitor the weather, enable military communications, and even power the timing systems that make the stock market function. And here's the kicker. Most of these satellites orbit along the equatorial plane, right where Earth's gravity is most stable, the very same space where a ring system would form. Now imagine that space filled with rocks. Not just a few pebbles here and there, but a dense, fast-moving belt of moon debris. Thousands, even millions, of chunks of jagged rock flying at orbital velocity. That's roughly 17,000 miles per hour. At that speed, even a marble-sized object becomes a deadly projectile, capable of obliterating a multi-million-dollar satellite in a flash. And these rings? They wouldn't be made of soft, fluffy stardust. Earth is too warm and too close to the sun to sustain icy rings like Saturn. Ours would be rocky, dark, and dangerous. Essentially an orbital minefield. That means goodbye GPS, no Google Maps, no Uber, no food delivery tracking, no Instagram stories posted from 30,000 feet in the air, no TikTok at all. Maybe that's a blessing or a curse, depending on who you ask. But it gets worse. Commercial airliners depend on satellite-based navigation to fly safely across oceans and continents. Remove that? Pilots are flying blind. Ships lose their positioning systems. Global logistics unravel. Imagine Amazon without the ability to track packages, cargo ports without coordination, markets without real-time financial data. Not only would online banking take a hit, the entire global economy would grind to a crawl. And what about the weather? Those chance of rain alerts on your phone come from data collected by Earth-observing satellites. Without them, we lose eyes on hurricanes, droughts, wildfires, and climate trends. Entire continents could be caught off guard by catastrophic storms or climate shifts. Early warning systems? Gone. Disaster response? Severely limited. Military operations? Much of national defense relies on space-based reconnaissance and encrypted satellite communications. No satellites, equals no secure communication, equals massive vulnerability. We'd be back to World War II-era tactics, relying on radio towers, ground-based radar, and guesswork. Now sure, engineers might eventually develop workarounds. We could put satellites in polar orbits, which move north-south instead of east-west, to avoid the rings. But polar orbits come with trade-offs. Coverage is less continuous, latency increases, and it would be harder to establish a reliable network for global communication. Entire industries would have to reinvent themselves from the ground up. There's another big casualty here. Space exploration. With a dense ring of debris circling Earth, launching rockets would become a high-risk gamble. Every spacecraft leaving or returning to Earth would have to thread the needle between high-speed rock fragments. Even the International Space Station, currently orbiting at about 250 miles above the surface, would be at risk if the lower edge of the rings dipped too close. In short, humanity would be grounded. Earth would become a technological prison, surrounded by a beautiful but deadly fence of stone. Space, once the great frontier, would now be a sealed vault, locked behind walls of rock. Think about that. We've spent over a century dreaming about colonizing Mars, building moon bases, reaching for the stars. A ringed Earth could put all of that on hold, permanently. Even if we could adapt to the loss of GPS, even if we managed to shift our tech to different orbits, we'd still live under the constant threat of a satellite-killing sky. And there's one more problem no one wants to talk about: debris collisions. The rocks in the ring system wouldn't just sit still, they'd collide. Constantly. Every impact would shatter fragments into smaller, sharper pieces, increasing the density of the ring over time. And eventually, those fragments would rain down. Burning through the atmosphere, yes, but some might survive re-entry. We'll explore that doomsday scenario in Part 5. But for now, remember this. A ringed Earth might make for some stunning Instagram photos, but it could mean the end of everything we've built to get there. There's a saying, nothing lasts forever. That's true for relationships, empires, and yes, even planetary rings. As stunning as they might appear in the sky, arching across the horizon like glowing scars of the cosmos, Earth's rings wouldn't be permanent. Over time, this beautiful halo would slowly begin to fall apart, piece by piece, rock by rock. And what begins as a celestial light show could eventually become a global threat, a ticking time bomb hanging just above our heads. Let's break this down. Even in space, nothing is perfectly still. The particles in Earth's rings would constantly jostle, collide, and grind against one another. Those collisions would create smaller and smaller fragments. That sounds harmless, right? Not quite. The more particles there are, the more collisions occur. It becomes a chain reaction, a growing cloud of dust and rock, swirling in a chaotic dance of destruction. Eventually, some of these fragments would lose momentum. They'd drift out of the safe orbital lane and start spiraling downward, pulled back to Earth by gravity. And then, they fall. Now, most debris that enters Earth's atmosphere burns up completely, giving us those stunning meteor showers we love to watch. But remember, these ring fragments wouldn't be your average shooting star. Some would be massive, chunks of moon-sized rock traveling at over 17,000 miles per hour. That's more than 20 times the speed of a bullet. And when something that big, moving that fast, hits the surface of the Earth, it's not a light show, it's a disaster. We're talking impact craters, tsunamis, and shockwaves that flatten cities, forests incinerated in an instant, oceans churned into boiling chaos. A single large impactor could do the kind of damage we associate with asteroid extinction events. In other words, the rings that once lit up the sky could eventually rain fire on us. We'd live in constant fear. Imagine watching the skies not with wonder, but with dread. Governments would develop elaborate radar systems just to track incoming debris. Cities might build protective domes. Helmets and underground shelters could become everyday necessities. Meteor insurance might become as common as auto insurance. Even more terrifying, we wouldn't know when it ends. Some fragments could fall every day. Others might hang in orbit for centuries before finally giving in to gravity. This wouldn't be a one-time cataclysm. It would be a drawn-out era of instability, like living under a crumbling bridge that's slowly giving way. But let's take a step back. What if Earth had always had rings, not created by destroying the moon, but formed from some other ancient collision in our planet's early years? That's an entirely different timeline. In that version of Earth, humanity might have evolved differently. Without a visible moon to guide ancient sailors or mark the passing of months, early civilizations would have created different calendars, myths, and technologies. Maybe we'd mark time by ring shadows instead of lunar phases. Maybe, without access to satellite technology, blocked by a sky full of dangerous debris, we'd advance in ground-based communication systems far earlier than in our real timeline. In a world where space is permanently closed off, perhaps humanity would look inward rather than upward, focusing on the oceans, the Earth itself, or even quantum technologies. We might build underground cities in the shadowed zones or construct entire civilizations adapted to colder, darker climates created by the ring's eclipses. Maybe that version of humanity would be smarter, tougher, or even more sustainable, never becoming dependent on satellites or space travel. Or maybe they wouldn't survive at all. Because even if we adapted to the shadows, even if we built a society that lived under rings from the start, those rings still wouldn't last forever. Eventually, the same cascade of falling debris would begin. Civilization, no matter how advanced or prepared, would still face the final truth of orbital decay. And with nowhere else to go, space locked off forever, there would be no escape. So, as beautiful as it might seem to live on a ringed Earth, it's clear now that beauty has a steep price. A world with rings might feel like a dream come true, until it becomes a waking nightmare. So what do you think? Would you want to live on a planet with glowing rings in the sky, even if it came at the cost of life as we know it? Let us know your thoughts in the comments. Would you choose beauty or stability? If you enjoyed this episode, make sure to like, share, and subscribe so you never miss another journey into the unbelievable. Thanks for watching What If, where we ask the biggest, wildest questions in the universe.